On today's episode, was the Titanic sub implosion an engineering failure? Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.com TV today. The tragic loss of OceanGate's Titan submersible with all hands aboard during a dive to the wreck of the Titanic has generated widespread speculation about the cause of the accident. As an experimental vessel, the submarine was not subject to conventional regulations on ship design and used an advanced structural material for a deep diving submersible, carbon fiber. Carbon fiber has long been popular in the aerospace industry as it combines the two most important attributes for any material used to build airplanes or spacecraft: lightweight with strength. Unlike many advanced materials, however, carbon fiber is also a favorite of experimenters and startup companies because of the way that large carbon fiber structures are built up. In aerospace, large assemblies such as wings and fuselages are assembled using fasteners, combining parts that must be forged, machined, rolled, formed, and bent using expensive tooling and sometimes large machines. Carbon fiber, however, can be built up on a mandrel or laid up by hand in relatively simple, open molds, a technique used commonly in the high-performance sailboat and yacht industry. It's critical in composite structures to ensure that multiple layers are well bonded with no trapped air, something accomplished by careful layup, which is usually followed by a vacuum impregnation process. It's difficult to get all the air out, and for safety-critical structures, an appropriate engineering safety factor is commonly built into the design. But in aerospace structures, the pressure is on the inside pushing outward, a classic hoop stress problem, and any crack or void in a carbon fiber fuselage barrel reduces the effective thickness of the structure locally and creates a site for crack propagation. While there is yet no definitive explanation for the implosion of the Titan submersible, the same basic principle applies. Excluding crushing pressure, which at the depth of the wreck of the Titanic is some 380 times surface pressure, well, that's a different problem from aircraft, which hold much lower pressures in, and it's likely that the investigations will include examination of the interface between the domes and the cylindrical main body structure. Deep diving research submersibles are commonly engineered as spheres, the most efficient form factor for pressure vessels. The use of carbon fiber for the Titan sub may have had more to do with the cost of manufacture compared to the very expensive and difficult process of machining and roll forming large, thick metal structures, but it will be some time before a definitive cause is determined. Carbon fiber is a viable material for pressure applications, and it's likely that in the wake of this tragedy, a standardized, globally accepted testing methodology will be developed for undersea use. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.